We already went to the moon, Neil Armstrong, Buzz Aldrin, the flags, the footprints. We did it 12 times between 1969 and 1972. So why are we going back? Why spend billions just to fly around the moon? Because the moon isn't just a destination. It's a gateway. NASA's long-term goal isn't just to visit the moon. It's to build a permanent presence there, a base, a launch pad, a staging point for something even bigger, Mars. But you can't just jump to Mars without understanding how humans survive in deep space for extended periods.
We're also going to do human research on the crew members themselves. We haven't had data sets for over 50 years on how the physiology of the crew themselves adapt to the radiation environment, to the microgravity environment so far away from Earth.
You need to test your equipment. You need to test your spacecraft. You need to test your people. The moon is our proving ground. If we can't survive 10 days in lunar orbit, we have no chance of surviving 7 months on a trip to the red planet. Artemis II is the bridge between being an Earthbound species and a multiplanetary one. And that's exactly what Artemis II is. The most critical test flight in a generation. It's not just NASA's mission either. This is a global effort. The Artemis Accords have brought together nations from across the world, united behind a single shared vision of the moon and what lies beyond it. America has not been idle. But now, after decades of planning and billions of dollars invested, the moment has finally arrived. People often ask, if they're not landing on the moon, what's the point of the trip? The answer is almost everything that matters. NASA is testing Orion's life support system with actual human beings for the first time. CO2 scrubbing, temperature regulation, water recycling, all of it runs in the real environment of deep space, with astronauts depending on it. They're studying how the human body responds to radiation beyond Earth's protective magnetic field. An experiment called Avatar will use organ-on-a-chip devices, miniature human organ tissue, to measure the biological effects of space radiation at this distance. They're verifying communication systems, spacecraft maneuvering, navigation accuracy, and re-entry precision. And riding alongside the crew are 5 international CubeSats. Small satellites from partner nations, including Germany, Argentina, and South Korea, each running their own scientific experiments about radiation materials and deep space conditions. Every piece of data collected on Artemis II makes Artemis III, the actual moon landing, safer. It's easy to look at Artemis II and think, okay, it's a test flight. Cool, but not the real thing. But zoom out for a moment. The United States is in a new space race. China has announced its own plans to send astronauts to the moon, and there's genuine concern that it could happen before America's next moon landing. The stakes are not just about flags or firsts. They're about who shapes the future of space exploration, who sets the rules, who builds the infrastructure, who establishes a permanent presence on the moon and, eventually, Mars. Artemis II is step 2 in a plan that goes moon orbit, moon landing, moon base, and then Mars. NASA Administrator Jared Isaacman said it clearly. America will never again give up the moon. And if Artemis II succeeds, the next few years will bring things we haven't seen in half a century. Boots on lunar soil. A woman stepping onto the moon for the first time in history. A human being standing on another world. All of it begins with this mission. We are living in the second great space race. But this time, it's not about who gets there first. It's about who stays. When those 4 astronauts look out the window of the Orion capsule and see the Earth rise, they'll be carrying the dreams of 8 billion people with them. The countdown has begun. April 2026. Mark your calendars.